All right, so we are continuing with our understanding slope and y-intercept with Agile Mind, topic 8, block 8 in your student activity book. Question number 1, we begin with Shauna earns $10 each week helping her grandmother with housework. Again, Shauna earns $10 per week helping her grandmother with housework. Instead of spending the money, Shauna decides to save her money in the bank. What a nice, responsible young lady. Complete the table to show the relationship between the number of weeks she worked and the amount of money that she saves. Okay, so in week 1, of course, it's $10 and the amount that she saved is $10. And then in week 2, it would be $10 plus $10, or put more simply, of course, that would be $10 times 2, right? Which gives us, or Shauna, I should say, a total of $20, right? And in week 3, well, then that's 10 plus 10 plus 10, or 10 times 3, which gives Shauna $30. And of course, in the 4th week, that would be $10 times 4 weeks, giving her a grand total of $40. I'm sure that you probably already filled out the rest of your table while I've been slowly plodding through this. Don't worry, $10 times 5, which gives us $50. And $10 times 6 weeks, which gives Shauna a total of $60. And now you can see in the last column, well, it's T for time, the number of weeks in T. Well, we would still keep the $10 right where it is, but now we're going to multiply that instead of times a number, we're multiplying it by the variable. And so and they're using the variable a here. So a is equal to 10t. Bum, ba, bum, right? Beautiful work. Beautiful, even if I must say so myself. Now, we are going to use the data from this table to construct a graphical representation of her problem situation. Does Shauna's savings vary directly with the time in weeks worked? And what does it mean for something to vary directly? Okay. Vary directly. That's a fun thing to say. Remember, varying directly means that there is a constant of proportionality, which means that there is a proportional relationship Okay, well, come on there. There we are. Sometimes my pen doesn't want to write when I ask it to. There is a proportional relationship between the amount saved, in this case, and the time in weeks, or usually it would be y and x. That's going to give us a constant, right? The constant of proportionality. And in this case, of course, that's a divided by t will give us a constant. Okay, so at 1 week we had 10. At 2 weeks it was 20. At 3 weeks 30. 4 weeks 40. 5 weeks 50. 6 weeks 60. 7 weeks 70. So does this savings, does it vary directly with the time in weeks worked? Okay. Is there a direct variation? Is there a proportional relationship? Well, of course there is. If you look, this line, if we were to connect all these points with a line, that line, if I had a ruler, would be a straight line that would pass through the origin, because at 0 weeks, she would have had no money in savings. But at 1 week, she had 10, 2 weeks, 20, 3 weeks, 30. And so every time, we can see that there is a proportional relationship. Her savings does vary directly with the time in weeks that she worked, because there is that constant every time that you divide the A, which was, in 10 divided by 1 is 10. 20 divided by 2 was 20. So there's always that constant proportionality in every week as they move on. Okay. So moving on to question 3, unless, of course, there are any questions. And remember, if you have a question, all you have to do is type your question into a question mark into the chat, and I will be happy. So to stop and answer that question. So in questions 1 and 2, oh, you're right. Yeah, thanks for catching that. Can't believe it. 20 divided by 2 is 10, not 20. And 30 divided by 3, that's 10. Yeah, so we get that constant. Thank you. All right. First mistake I've made all day. Question 3, it says, in questions 1 and 2, you created a table and a graph to represent Shauna's saving situation. And we also wrote a rule where A represents the amount of money saved and T represent the time in weeks. All right. If you remember that was A equals 10T, right? Now, each week, the amount of money in Shauna's savings account increased by $10. Where do you see this constant rate of change in each representation? Okay, well, if we go back up, it's easy to see that rate of change, right? We can see that constant rate of change right here because it passes through the origin, but there it is. Every time that we divide one by the other, A divided by T, we're going to get that 10, just like in the table. Every time we divide A by T, we're going to get that 10. 60 divided by 6, 50 divided by 5, 40 divided by 4. Every time we're going to get that constant rate of change. So the great thing about this equation that we see right here, A equals 10T, we can rearrange this by manipulating it just a little bit. A equals 10T. What I'm going to do is I'm going to divide this side by T and this side by T. Now, this is a single step equation. So when I do that, that one and that one cancel each other out. And so my other equation that I can use would be A divided by T equals 10, which is our constant of proportionality. Very nice. Very nice indeed. And let's see. Moving on to question 4. Manuel worked all summer at an amusement park and saved $1,050. At the end of the summer, he stopped putting money into the account and instead began making weekly withdrawals. Manuel made this table to represent the activity in his account. Describe precisely what is happening to the amount of money in Manuel's savings account. Does Manuel's savings amount vary directly with the time in weeks worked? Let's read that one more time just to make sure we understand what it says. You know what? We're almost out of time, and so we're not going to be able to read this one. We'll continue this one the next time that we get together to discuss it. Probably end up being Thursday, so don't worry.